Hello everyone, you are welcome. Today we have a new interesting geometry math problem. That is, here we have given two circles such that the length of this chord in a smaller circle is 9 units, where the length of this chord in a bigger circle is 16 units. Our target is to find out the area of this bigger circle. Now to find out the area of this bigger circle, we know that the area is 5r square. So here we need the radius of this bigger circle. Now to find out the radius here, for that we will do some steps here. So first of all, let us give one names to the points. Let us suppose this is point A, this is point B, this is point C, and this is point D. Now first of all, here we will try to find out the length of this BD, which is a tangent to this circle as well as this circle. Now to find out the value of this BD, here we will use a result. That is, if BD is a tangent to a circle and AB is a line segment such that AC is a chord on this circle. So here the square of this BD will be equal to the product of BC times BA. So here we will use this one result and we will find out the value of this BD. So here we can write the square of BD, that will be equal to BC times BA. And we will try to find out the value of BD. So we substitute the value of BC, which is 9 units, and the value of BA, which is 16 units. So this will become BD square is equal to, this is simply 9, and this is 9 plus 16, which is 25. Here we will take square root on both sides. So this will become BD is equal to square root of 9 is simply 3 and square root of 25 is 5. So the value of this BD will become 3 times 5, which is 15. So this is the length of BD. So here this BD is 15 units. Now what we will do next? Next, here we will draw a tangent to these two circles at point C such that the tangent join this line segment BD, and we will also draw this D with point C. So this figure will become, let us suppose this is point E. Now what we will do here, we will try to prove this angle at point C is a right angle, 90 degrees angle. So for that, here we will use a result, tangents to a circle theorem. Now if we have two tangents from an external point to a circle, then the length of that tangents will be equal. So here we have two tangents from this point E to this circle, tangent EB and tangent EC. That will have the same length. So here these two line segments will be same. Similarly, we have two tangents from point E to this bigger circle, tangent ED and tangent EC. So these lengths will be also equal. These tangents will be also equal. So here we have two smaller circles, circle DEC and circle BEC. Now look at this one circle here. These two sides are equal. So here their opposite angles will be also equal. So let us suppose this angle is equal to alpha and this angle is equal to also alpha. Now look at this one triangle CEB. Here these two sides are equal, so their opposite angle will be also equal. So let us suppose this angle is beta. So this angle will be also beta. And we also know that the sum of all angles in a triangle is always equal to 180 degrees. So therefore from here we can write the sum of these angles, which is alpha plus beta plus beta is equal to 180 degrees. So this is 2 alpha plus 2 beta is equal to 180 degrees. Let us take 2 common. So this become alpha plus beta is equal to 180 degrees. Now dividing both sides by 2, this gives same alpha plus beta is equal to 90 degrees. So here this angle, which is the sum of alpha and beta, this is a 90 degree angle, right angle. And we also know that the angles on a straight lines are always 180 degrees. So here this angle is 90 degrees, so this angle will be also 90 degrees. Now here we will join this A with point D. So this figure will become, now by Thales theorem, here this AD will be the diameter of this circle. This is because by Snell's theorem, if we have a triangle in a semicircle such that the bigger side is the diameter of the circle, then its opposite angle will be a right angle, 90 degrees angle. But here in this case this angle is 90 degrees, so here this side will be the diameter of this circle. Now here the angle at point D will be also a right angle. This is because here the diameter of a circle is always perpendicular to the tangent line. So here this is perpendicular, so here this angle will be a right angle, 90 degrees angle. But here this triangle ADB is a right angle triangle. Now we will try to find out the value of this AD, which is the diameter of this circle, because the radius is the half of the diameter. So for that, as this is a right angle triangle, triangle ADB, so here we will apply the Pythagoras theorem and we will find out the value of this AD. So by Pythagoras theorem, we can write hypotenuse square is equal to base square plus perpendicular square. So our hypotenuse is AB, base is BD, and our perpendicular is AD. So this figure will become here in triangle ABD, hypotenuse square is equal to hypotenuse is AB, so this square is equal to base square, that is BD square, plus perpendicular square, that is DA square. Now to substitute the values from the figure, so here hypotenuse is 25, so it become 25 square. BD is the base, which is 15, so it become 15 square, plus DA is the perpendicular, which is not given, which is our target to find. So 225 square is simply 625 is equal to 15 square is simply 225 plus DA square. And we will take this number to the left hand side. So the value of DA square will become, this will become 625 minus 225. So DA square will become 625 minus 225 is simply 400. Here we will take square root of both sides. So the value of DA will become square root of 400 is simply 20. So here the value of DA is 20 units. So here the perpendicular and the diameter of this circle is, this is 20 units. No, the diameter is 20 units. So what about the radius? As we know that radius is the half of the diameter. Diameter is 20, so its radius will be half of 20, which is 10 units. So here the radius is 10 units. So the area of this circle will become, as we know that area of circle is pi r square. So therefore area of the above circle will become phi r square. But here the value of radius is 10, so it will become pi times 10 square. Now 10 square is simply 100, so it will become 100 phi. But we also know that the value of phi is about 3.14 up to 2 decimal places. So multiply these two numbers, so this will become 340 units square. So finally this is our answer. So finally the area of this bigger circle is about 340 square units or 100 phi. Now this is our final answer and final target. And last, don't forget to subscribe my YouTube channel for such a more interesting and step-by-step geometry math problems. Thanks for watching.